This is 7.4 of algebra. So we're going to continue working with exponents. Now we're going to look at it when we're dividing exponents. So if you think of x to the fifth over x squared. If I write that out the long way, this is x times x times x times x times x over x times x. And if you think about something like 3 divided by 3, that's just 1, right? And 7 divided by 7, that's 1. 1,000 divided by 1,000, that's 1. Anything over itself is just 1. So I can get rid of these two, because that's just 1. And I can get rid of these two, because that's just 1. And so I'm left with x to the third. Can you look from here to here and see a shortcut? All we have to do is subtract the exponents. So our general version, a to the m over a to the nth is equal to a to the m minus n. So let's try that. I'm going to give you one that's not on here, a little easier one. If we have z to the seventh over z to the third, we get z to the 7 minus 3, which gives us z to the fourth, right? You just subtract. So if we look at a here, I've got y to the 3/4 over y to the 1/2. So I need to do 3/4 minus 1/2. Well, to subtract fractions, I need to have common denominators. So I need to change 1/2 so that it has 4 in the bottom, in the denominator. To get from 2 to 4, I need to times by 2. So on the top, I also need to times by 2. So I get 2 over 4. So instead of 1/2, I can write this as 2 over 4. 3/4 minus 2/4, that's just 1/4. So this is equal to y to the 1/4. Let's try this one right here. K to the sixth j squared over k j to the fifth. If there isn't an exponent, there's a 1. Okay? So 6 minus 1, that gives me 5, so k to the fifth. And then 2 minus 5, that gives me j to the negative 3. Okay, then we need to move the negative, right? So this is k to the fifth over j to the third. Okay, that's one way you can do it. Another way that you can do it is you can say, okay, well, the 6 minus 1 would still be the same. So 6 minus 1 gives me k to the fifth. But then if you want, you could say, okay, 5 minus 2 gives me 3. And where were there more j's? There were more j's on the bottom. So I get j to the third on the bottom. Both ways are going to get you the right answer, right? It's just whatever you need to decide the best way for you to think about it, okay? If you struggle with remembering rules, it's probably the better idea to just always to do this way and just always subtract it. Your choice. The other way does work. Okay, let's try D. I'm going to switch colors here. 2 different ways you can do this one also. Okay, we can just do the regular subtracting. Okay, so we got a to the negative 3, b to the 7th over a to the 5th, b squared. So negative 3 minus 5. Negative 3 minus 5. That gives us a negative 8. So this is a to the negative 8th. And then for b, we get 7 minus 2, which is 5. And then we need to move this. So b to the 5th stays on top, and a to the 8th moves to the bottom. The other way that you could do this, okay, so from this one, right away you could say, hey, that's a negative exponent, so I need to move it to the bottom. So you could leave b to the 7th on top, move that a to the 3rd to the bottom, and we've also got a to the 5th on the bottom, and b squared on the bottom. Before I do anything, I'm going to simplify these two down here. So b to the 7th stays on top. That turns into a to the 8th because 3 plus 5 is 8. And then I've got my b squared. And then I can subtract my b's. B to the 7th and b squared, 7 minus 2 is 5. So this is b to the 5th over a to the 8th. So a couple different methods there. Your choice on which one you want to use. If I were you, I'd rewind this, watch this again, and decide which one you want to use. Okay, we can also divide in scientific notation. So, down here we've got 7.33 times 10 to the 6th divided by 4.33 times 10 to the 4th. So I'm going to split these up so that I get 7.33 divided by 4.33 times 10 to the 6th over 10 to the 4th. So what you need to do is the numbers up front, these ones right here, we're just going to divide that on a calculator. So 7.33 divided by 4.33 gives us about 1.69 times, and then, 69, that's 9. And then to divide my tens with exponents, what's 6 minus 4? Well, that's 2, so this is 10 squared. And so my answer is 1.69 times 10 squared, or 10 to the second. Okay, if we have parentheses with the exponent outside, so if we have a over b squared, we would simplify that a squared over b squared. You need to distribute the square into everything, okay, into the top and into the bottom. If I had let's do 2z over y squared, and this is to the third, you need to bring it to everything. The 3 needs to go to the 2, to the z, and to the y. So this will be 2 to the third, z to the third, over y to the 2 times 3, right? 2 to the third is 8, z to the third, and this would be y to the 6th. Okay, so here's our generic form right here. A over b to the n is equal to a to the n over b to the n. So, let's try a few. We'll try their got it problem. 4 over x to the third squared. So I need to rein in the 2 to the 4 and to the x. So this is 4 squared over x to the 3 times 2, which gives us 16 over x to the 6th. Let's try one more. Let's do z to the 4th over 3x squared, all that to the 3rd. So the 3 needs to go to the z, to the 3, and to the x. So this is z to the 4 times 3, 3 to the 3, and x to the 2 times 3. On the top we get z to the 12th over 27x to the 6th. And that would be our answer. What if we have a negative exponent outside of our parentheses? So your book tells you one way, but I'm going to show you a different way that I think is a lot easier. If we have, let's just do x over y to the negative 3, okay? Rein the negative 3 in, so this turns into x to the negative 3 over y to the negative 3. Whenever we have a negative exponent, we have to move it, right? So the x needs to go down, and the y needs to go up, right? So I'll move my x down, so x to the third is on the bottom, and move my y up, so y to the third is on top, and that'd be my answer. Okay, so I think it's easiest if you want to do the book way, you may, but I think it's easiest if you just rein in the negative and then move things. So let's try a few examples. So we've got, for our got it problem, a over 5b to the negative 2. So I'm going to rein in that negative 2 to everything. So this is a to the negative 2 over 5 to the negative 2, b to the negative 2. So I need to move things. So the a to the negative 2 needs to move the bottom so that we get a squared. The 5 needs to move up so we have 5 squared. And the b needs to move up so we have b squared. 5 squared is 25, so this turns into 25b squared over a squared. And there's your homework.